Welcome to the final revision for math exam. Before we start with any question, I have to say that there are many formulas and ideas that you have to be familiar with in order to be able to solve all of these questions no problem. That being said, we can start with the first question, which is if matrix A, which is this one, the element, and element here they mean by number. So the number of the order A 3 cross 1. Okay, so what does 3 cross 1 means? First of all, we have to know that the first number here represents the number of rows. And the second number here represents the number of columns. Okay, so if we go to the third row in this matrix, so this is the first row, this is the second row, and this is the third row. So we are here. And then we go to the first column as stated here. We go to the first column, which is this one. So we see that the intersection happens at number 1 or element 1. So the answer for this question is 1. We can do the same thing here. So number of rows is 1, number of columns is 3. So we go here. So this is row 1. And this is the third column, which means that the intersection happens at element number 7. So here the answer is 7. Okay, so if the matrix A with the order 2 cross 3 is multiplied with matrix B, the result matrix is AB, which is their multiplication, or their product is equal to this product, which is, or this order, which is 2 cross 2. Rank of matrix B will be. So in this question, what essentially they are asking is, they give us the matrix or the order of the first matrix, which is 2 cross 3, and then multiplied by B without an order, will equal the product with here. The order is 2 cross 2. Okay, so now essentially here they are asking us what is the order of B, assuming that we have the order of A and the order of their product. So first of all, we have to know that in order for these two matrices to be able to be multiplied with each other and can be conformable, the number of columns in the first matrix should equal to the number of rows to the second matrix, which means that the first number here is 3. Because here we have 3, the closer number should be also 3. Okay, so then we got the first number. Now how do you get the second number? Now we can just eliminate the common thing. So we have here 3, we have here 3, we have 2 and 2 here, which means the last number we have is 2. So our the order for matrix B is 3 cross 2. Let's make sure that we have the right answer. So to be able to check it, we multiply here. The order of matrix A is 2 cross 3, and the order of matrix B is 3 cross 2. Does it equal to AB with the order 2x2? So we can go here and first of all remove these two, so essentially now they are conformable, so we can just remove them, and we can take now the first number and or the number of rows in matrix A and the number of columns in matrix B, and we plug them together. So A, B with the order, here we have 2, here we have 2, so 2 cross 2. And this is equal to this, which means that we have the right answer. So let's do it another time, but this time a bit quicker. So let's say we have matrix A, which is 4 cross 3 times matrix B without the order will equal AB, their product, with the order 4 cross 2. So the number here is 3, so here should be 3 cross. Now let's remove common numbers. So 3, 3, 4, 4, last number is 2, which means that order of B is 3 cross 2. And to make sure that we have the right answer, we can do the same thing we did in this question. Okay, so let's go to the second page. Okay, so in this question, they're telling us that the first element is equal to the second element according to this sign. And the second element in the first matrix equals the second element in the second matrix, which means that we can here form equation 2a minus 1 should equal 5, and the second equation is negative 3b should equal negative 3. Okay, so we can just get the value of a by putting negative 1 to the other side, which will make it 2a is equal to 6, divide by 2, which means that a is equal to 3. So we got the first one, which is 3. In the question, they're asking us what is a minus b. So first number is 3. Now we put minus, and let's get b. B is equal to, if we divide it by negative 3, then negative 3 and negative 3 will go, and negative 3 divided by negative 3 will equal 1. So b is equal to 1. Okay, so 3 minus 1 will equal to 2. Second question, same idea. 2a minus 1 is equal to 7. Negative 3 b is gonna equal to negative 3. Okay, so again, transfer negative 1 to the other side. We'll get 2a is equal to 8. Divide by 2. A is equal to 4. 4. We put minus, and then divide by negative 3. Again, this will equal 1. Just like this, the first equation. Same thing. So 4 minus 1 is equal to 3. And this is the answer. So here, they give us if x, or the matrix of x is equal to negative 1, 6, 4, negative 5, then what is x transpose? So what does transpose mean? Transpose basically means that you take the row and transform it into a column. To get a visual representation of this, we can just copy this row and we can turn it into a column. So here we can see our new column is going to be negative 1 and 6. Okay, and we can do this again. So let's write our answer. So negative 1 and 6, and let's do the same thing for the second row and turn it into the second column. So it will be 4, negative 5. So this is like more of a visual representation. Usually you just do it by imagining it. And to make sure that you have the right answer, the first element should equal the first element in the transpose version. Same thing with the last element, they should equal each other. So negative 1, negative 1, negative 5, negative 5, both equal each other, then we have the right answer. So same thing, but this time we'll do it a bit quicker. So we'll take negative 1 and 4 will be down. Again here 3 and negative 5. We see here negative 1, negative 1, negative 5, negative 5. They're equal to each other, which means that we have the right answer. We can go to the fourth page. Okay, so to the fourth page. Here they gave us matrix A and matrix B. Then they ask us what is 2A plus 3B. So what is essentially asked here is to multiply the entire of matrix A times 2 and to multiply the entire matrix B times 3. Okay, so let's get each one. So matrix A is going to equal, or 2A, 4 times 2 is going to be 8, 2 times 3 will be 6, 2 times negative 2 will be negative 4, and finally 2 times 1 will be 2. Okay, then we put the sign here, so plus, and then the second matrix, which is what do they, yeah, 3. So let's multiply 3 by each element in matrix B. So we have negative 3 times 3, which will be negative 9. 3 times 2 is 6, 3 times 5 is 15, and 3 times 7 is 21. Okay, so here we can now just add the elements with each other. And in order for matrix A, okay, so if you say matrix A plus matrix B, their order must be identical to each other. Okay, so matrix A and matrix B should equal each other. So in case this was 2 cross 2, matrix B's order should be also 2 cross 2. In this case, this is 2 cross 2. The second matrix order is also 2 cross 2, which means they are conformable. So we can now just add them, which will be here 8 plus negative 9, which will equal to 1. So we can just remove this. We'll do the same thing with each one. So 6 plus 6 will be 12. Negative 4 plus 15 will be 11. And finally 2 plus 21 will be 23. Okay, so this is our answer. Now we can do the same thing here. Times everything here by 4. Times everything here by 5. Okay, so 4 times 4 16, 4 times 3 is 12, 4 times negative 2 is negative 8, and 4 times 1 is 4. Now plus, just as asked in this question, the second matrix. So here 5 times negative 3 will be negative 15. 5 times 2 will be 10. 5 times 5 will be 25. And finally, 5 times 7 is 35. Okay, so now we can just add each element. So 16 plus negative 15 will give us negative 1. Let's just make it a bit. Okay, yeah, that's much better. So negative 15 plus 16 is going to equal negative 1. 12 plus 10 will be 22. 25 plus negative 8 I believe will be 17, yeah. And finally 4 plus 35 will be 39. So this is our answer. Now we can move on to, yeah, multiplying. In order to multiply, as we said, the number of rows in the first column, or in the first matrix should equal the number of uh, rows, yeah, the number of columns in the first matrix should equal the number of rows in the second matrix. So here, how many columns we have? We have 1 and 2 columns, and the second matrix we have 2 rows, which means they are conformable. So now we can just get the answer fairly quickly. So 5 times 5, we'll put 5 times 5 plus, and we can go to the second number, which is negative 2 times negative 2. So negative 2 times negative 2. And now we can close it. Let's just make it smaller so it makes sense. So 5 times 5 is going to equal to 25, plus negative 2 times negative 2 is going to equal 4, which will equal 29. So this is our answer. We can do the same thing here. So 5 times 4 will be 5 times 4 plus negative 2 times negative 3, so negative 2 times negative 3. Close bracket. Again, 5 times 4 is going to be 20, plus negative 2 times negative 3 is going to be equal 6, positive 6. And finally, we can just add them, which will give us 26 as our final answer. Okay, so we can now move on to solving the system, and they gave us the equation by using multiplicative inverse. So we'll know what multiplicative inverse means in the beginning, but for now, let's convert these equations into matrices form. So we'll take the first equation, and we'll write the coefficient for each variable. So here we have 3, so let's write here 3, and here we have 5, so let's write 5. And do not make the mistake of taking 27. 27 is for another thing. So here we have 3 and 5, and now we can go to the second row by taking the second equation. So we have 2 and 3. So this is this equation in matrix form. Now this times the matrix x over y will equal what? Will equal what the two equations are equal to. So 27 and 17. 27 here over 17. So what essentially we want to do is, let's label first this matrix as A, this entire matrix as X, and this matrix as B. So we want the value of X. We want the value of matrix X, which will give us both X and Y. And how we'll do that? We want to separate it and isolate it. So we'll have to get A to the other side. We'll have to divide both sides by A. But we cannot divide in matrices, so what we will do is write or times the inverse of A in both sides. So here times inverse of A. So this will go with this, and now essentially you'll have the value of X, which is what we want, is going to equal to B times A inverse. Okay, so what does A inverse means? A inverse is basically going to equal to, so here A inverse is going to equal A adjoint over A determinant. Now what does each of these mean? A adjoint, so that is when you take the okay, let's work with the matrix that we will be answering with. So copy. So the adjoint of this matrix is basically taking these two together. Let's label these as A, and taking these two together, and let's label them as B. What we'll do is we will transform both A and B's positions, or sorry, 3 and 3, so that's for A. And for B, we'll just take, for the numbers in element B, we'll just take the inverse sign, which will mean that it will equal to, here, Since 3 and 3 are equal to each other, so nothing will change. But for example, if we had the matrix 2, 5, 7, 6, so if we want to write the adjoint, as we said, this will become 6 will switch position with 2, so it will be 6 and here 2. And as we said, we'll take the inverse sign, so this will become negative and this will become negative. So we'll write negative 5 and negative 7. Okay, so here what do we have? So 3 and 3 we switch positions, and finally we have to make 5 negative, and we have to make 2 also negative. And in case one of them were already negative, we'll make them positive. Just take the opposite sign. Okay, so this is a adjoint. This is a adjoint. That's what's it equal to. So let's write this matrix, which is 3, negative 5, negative 2, 3. So here, A inverse is going to equal 3, negative 5, negative 2, 3, divided by, what is A determined? A determined, you will take, so we'll do the same thing. We'll label this diagonal as A and this diagonal as B. So we will multiply 3 times 3 and then minus it by 2 times 5. So let's write 3 times 3 minus 2 times 5, 2 times 5, which will become 9 minus 10, and this will equal to negative 1. Okay, so essentially A determined is going to equal negative 1. Here, let's write it. Negative 1. So we have to divide each element in the matrix by A determinant, which is negative 1. But since it's negative 1, we can just switch the signs. It will stay the same. No element's value actually will change. So 3 will become negative 3, negative 5 will become 5, and then negative 2 will become 2, and 3 will become negative 3. We just took the opposite signs. So this is A inverse, but this is not what we want. This is not our answer. Our answer is to get X and Y. And how do we do that? We said X is going to equal A inverse times B, which is 27 over 17. Okay, so let's write this here. Let's just transform it. Okay, so as you said, we'll take the first row here. We'll take the first row times it by the first column. So it will become like negative 3 times 27 plus 5 times 17. And since here we have a second row, so we will take 2 times 27 and we will take make a new row. So it become 2 times 27 plus 3 times 7, negative 3 times 17. So this will equal to, I believe, 4 over 3. So this will equal to X over Y, or the X value. This is what we named X after, which means that 4 is going to equal X and 3 is going to equal Y. So if we go back here, we can substitute each element. So let's just remove these for a moment. My bad. Let's just remove these. So if we said that X is equal to 4, so 3 times 4 is going to equal 12 plus, and we said that Y is equal to 3, so 5 times 3 will be 15. So 12 plus 15 is going to equal 27, which means that we have the right values for each X and Y. Okay, so let's just get this back. Okay, we can do the same exact steps in this question. If anyone struggles with it, I can do another video for it, but just to cut some time, I will just skip it. Okay, so basic trigonometry or basic trigonometric identities. In this section, this is where you're going to need to memorize a lot of formulas, but in case you hate memorization, you can just work with each of these, okay? And you'll have to play with the values until you get the answer that you want. So here 1 plus, there should be a plus here, 1 plus tan squared x, what is it going to equal to? So if you remember the identities, you'll say right away 6 squared x, but how? So we can just transform tan square x into sine square x over cosine square x, because essentially tan is equal to um, sine over cosine, and tan x is going to equal to sine x over cosine x. Tan squared x is going to equal sine squared x over cosine squared x. What I'm saying is that whatever you do with tan, you will do with both sine and cosine. Okay, so this plus 1, so let's make it 1 over 1. What will it equal to? So here we can just um, make the denominator common, and let's multiply this by this and these two together. So it will give us 1 times sine squared x will give us sine squared x plus cosine squared x, so cosine squared x over 1 times cosine squared x. So 1 times cosine squared x is going to equal 1 cosine squared x. Okay? Now what will this equal to? So what we essentially can do is sine squared x plus cosine squared x is equal to something. If we remember the identity, sine squared x plus cosine squared x is going to equal 1. So we can just remove this and we can write 1 instead. So finally, our answer will be 1 over cosine x. In other words, it is sec squared x. So this is how we got the answer. Here, sine 2x. So let's first of all know what is sine x or sine a plus b. So sine, or let's make it sine x plus y. So sine x plus y is going to give us this formula. Let's just, okay, I'll write it here. So sine x plus y is going to equal, we'll take sine x times cosine y plus cosine x times sine y. So this is what sine x plus y equal to. Okay, now what is sine 2x? Sine 2x is basically taking y and making it an x. So now we have x plus x, which is 2x. So with every time we have y, we'll transform it into an x. And here we have an x. So we have now sine x times cosine x plus cosine x times sine x. This will equal to 2 sine x cosine x. It doesn't matter that the order here is different. Like here we have first sine, then cosine, and here we have cosine, then sine. Saying xy plus yx is equal to either 2xy or 2yx. Same thing, just up to the person. So this is the formula for sine 2x, which is 2 sine x cosine x. And let's just put it there, so it makes sense, it's smaller. Okay, so what is cosine 2x? Same exact thing and same idea. So cosine 2, or let's write x plus y, just like with the first one. It will equal to, here it will be, I believe, cosine x times cosine y. But this time we'll take the inverse of the sign. So in sine, we took the same sign. But in this, with cosine, we'll take the opposite sign. So it will be minus sine x sine y. Okay? Again, we'll take y and we'll remove it and we'll put x instead of it. So we'll have now cosine 2x, and it will equal to, let's make this an x and let's make this an x. So cosine x times cosine x is basically cosine squared x minus sine x times sine x is going to equal to sine squared x. So this is our answer. And we have to also know that this formula has two versions, which are in terms of sine and in terms of cosine. So how do we convert it into in terms of cosine? In terms of cosine, it will become 2 cosine minus 1, so 2 cosine squared, here 2 cosine squared minus 1. And in terms of sine, it will be 1 minus 2 sine squared x. Okay. Now we can go to the third question, fourth question actually. One for three. Okay, yeah, fourth question. So what is 1 minus sine squared x? Again, we've used the identity already, which is sine squared x plus cosine squared x is going to equal 1. So if we transform sine to the other side, we'll get cosine squared x is equal to 1 minus sine squared here squared x. So these two values here, these two values are the same thing. And what do they equal to? They equal to cosine squared x. Finally, here is the same thing. So instead of we put here, where is it again? Okay, let's just write it again. So here we wrote again cosine squared x plus sine squared x is going to equal 1. So this time we put cosine to the other side. So sine squared x is going to equal to this. So this is the answer. I think we can move on. Yes. Okay, so more evaluating the trigonometric expression. So here I believe we have plus again. So let's just write plus. So what is cosine squared x plus tan squared x times cosine squared x? So cosine squared x, we write it the same. We won't change anything with it. Plus, we've learned that tan squared x is equal to sine squared x over cosine squared x times cosine squared x. So we can cancel these two together, and it will leave us with only cosine squared x plus sine squared x, which we said again here, it is going to equal to 1. So the answer here is 1. Again, cosine squared x times secant squared x minus cosine squared x. So here we have cosine squared x. We won't change anything with it, but instead of secant, we write 1 over cosine squared x minus cosine squared x. So usually, since these two together are opposite of each other, so we'll just cancel them out. But I wrote them in this type of formula so it can make sense. So we can ضرب and ضرب, as Mr. Haya says, with these two, because they're equal to each other, and it will leave us only with 1. So it will leave us with 1 minus cosine squared x, which, as we said before, it will equal to sine squared x. Finally, as we just said, sec and cosine are the opposite of each other, so it become 1 times cotan x, which is essentially equal to cotan x, or maybe in the exam it will be cosine x over sine x. Cotan is the opposite of tan, so yeah, tan is sine over cosine, while cotan is cosine over sine. Okay, so here we have 2 cosine. Okay, let's go to this first because this will make more sense. 2 cosine square x minus 1. We've already said before that this is equal to, we wrote the 3 versions of cosine 2x, and the version in terms of cosine is equal to this one. So this is equal to cosine 2x, okay? And if we go here, we see that instead of minus 1, here we have plus 1. So what did they do? They essentially just added 2 on both sides, because here it was negative 1, so plus 2, it'll become 1. So we'll add 2 on the other side too, which means that the only missing thing is cosine 2x. So yes, both of these have the same answer. I think maybe they meant to put 2 as the missing, and they already give you cosine 2x, but in case they didn't make any mistake, then yes, both this question and this question have the same answer. Finally, sec, so let's write it as 1 over cosine x times sine x times cotan x, which we said is the opposite of tan. So cosine x over sine x, and this is going to equal to, okay, so sine and sine will go, cosine will go, leaving us with only 1, which means the answer of this question is 1. Okay, last page. So in order to solve this page, we'll have to memorize the entire unit circle, or not memorize, but understand, along with a couple of ideas. It will be fairly easy. Okay, because in the test you won't be provided with a unit circle. That's why I'm not advising you to rely on it. Before we start in this slide, we will need to know two important ideas. The first idea is if we want to get an angle in the first quadrant. So in the first quadrant, the angle will be the same thing. It'll be the angle. But for example, if we want to transform it into the second angle or the second quadrant, so it will be 180 minus this angle. Again, with the third quadrant, it will be 180, but this time plus the angle. And finally, if you want to get in the fourth quadrant, it will be 360 minus this angle. So this may not make any sense now, but it will make sense in a bit once we start solving the questions. So this is the first formula that we have to remember, or four formulas actually that we have to remember. Now to the second idea, which is ASTC, which is all students take calculus if we want to memorize it. This is basically saying that in the first quadrant, so as we see here in the unit circle, it is divided in four sections. And we call these four sections as, quadrants. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant, okay? So here, what does A means? It means that in the first quadrant, all trig functions are positive. So sine, cosine, tan, cotan, sec, like all of the trig functions with their reciprocals. In the second quadrant, it will be only sine and its reciprocal that will be positive. The rest will be negative. So tan and cosine will be negative in the second quadrant. Now, okay, let's just here write all so we can remember it. In the third quadrant, so this is the second, this is the first, and in the third quadrant, only tan and its reciprocal will be positive, and cotan will be positive. Here's the same thing, cosec. And finally, in the fourth quadrant, only cosine and sec, because it's sec is the opposite of cosine, will be positive, and the rest will be negative. Okay, so that being said, we can start solving the questions. So here they're asking us what is sine x that is equal to 1 over 2. They're basically asking us what is the value of x, and they determine 0 to 2 pi, which is basically saying the entire unit circle. So from 0 to 360. Okay, so we can put sine to the other side. So x will equal to sine inverse of 1 over 2. So what is sine inverse of 1 over 2? We go to the unit circle, and we have to know something very important, which is that the first number is representing cosine, and the second number is representing sine. So may say here, okay, we have 1 over 2, but no, this is for cosine. We're asking for sine 1 over 2, which means that we'll find it in angle 30. So angle 30 is 1 over 2, which means that sine inverse of 1 over 2 is 30. But hey, remember that they ask us for all of the angles found. So if we go to AST or ASTC, we'll see that sine is only positive in both the first and second quadrants. Okay, so in case you don't have the unit circle, you can first of all get the calculator and write sine inverse of 1 over 2. It will give you 30. But how do you get the other angles? You will use this formula. So we said that sine will be positive in the second quadrant. So we go to the second quadrant and we use this formula. So we'll say 180 minus the angle, and this time it is 30. So it'll equal to 150. Be careful, you don't want to take all of the angles. For example, here you have negative 1 over 2, but that's negative. We don't want this. We only want the positive ones. Which means that the two angles are 30 and 150, because in the third quadrant it will be tan, and the fourth quadrant it will be cosine. So we'll only care about the first two quadrants for sine. Moving on to the second question. What is cosine 1 over 2? Same thing. We'll put cosine to the other side. So x will equal to cosine inverse for 1 over 2 positive. The determinant is the same thing from 0 to 360. So it will be, just let me make sure about something. Okay. I can check later on. So what is the cosine inverse of 1 over 2? If we go to the unit circle and we try to find it in the first, so if we call this x and y, so in the x section, we'll find that 60 is equal to cosine 1 over 2, or the inverse of cosine 1 over 2. So it will be 60, okay? Now, what is the second number? Okay, like you're in the exam, you don't have the unit circle, what do? Again, you use ASTC. So where's cosine positive? It is positive in the first quadrant, and it is positive in the fourth quadrant, because second quadrant is for sine and the third quadrant is for tan. So fourth quadrant will be positive. So here we go to the fourth quadrant's formula. It will be 360 minus the angle, and this time the angle is equal to 60, so it will equal to 300, which means that the second angle here should equal 300, and we can go to the unit circle to check. And if we go to 300, yes, cosine is equal to 1 over 2. Okay, so let's move on to the third question. Yes, third question. What is tan 5 pi over 1, or sorry, 12? There should be a 1 here. What is 5 pi, or tan 5 pi over 12? Find the exact value. So here they're asking us for the exact value. Um, and for this one, the unit circle won't help us as much. You'll need to use your calculator, but to some extent you'll need to show your work. So how would you do this? Basically, first of all, let's convert this into degrees, because here it is in radian, or radian. So we'll say 5 times 180, because each pi represents 180, over 12. This will give us 75 degrees. So here they're asking us, what is tan 75? The exact value for tan 75. In this case, we don't have 75. It's not a number that we can find in a unit circle. So what do? We use our four angles, lovely angles here, which are 30, 45, 60, and 90. And with these, we can get many combinations of numbers. So you can see that 75 is a combination made up of 45 and 30. So we can write here tan 30 plus 45. So it's the same thing. It's going to equal to 75, but we've just broken it up because we have a formula for this. So what is tan x plus y going to equal to? The formula for this one, it will be tan x plus, so in the there will be a fraction, but in the numerator we'll take the same sign, so it'll be tan x plus, just, yeah, tan x plus tan y, and the second, or in the denominator, we'll write the inverse sign, so it'll be 1 minus tan x, and this time we will multiply with tan y. Okay, so we can represent this as x, and we can represent this as y. So if you write it here, it will become tan 30 plus tan 45 over 1 minus tan 30 again times tan 45. Okay, now I don't really remember all of them, so we'll have to use the unit circle. Okay, so now it's clear. So we said before that tan is equal to sine over cosine, right? So let's go here. What is tan 30? Let's get first of all the value of tan 30. If we go to the angle of 30, we'll find that this is sine and this is cosine. So we'll basically divide 1 over 2, which is the value of sine, divided by the root of under root of 3 over 2. So this is cosine. So you can see here we have sine divided by cosine, but this time we have their exact values. And now plus tan 45, so we can go to 45. We'll do the same thing. It'll be root 2 over 2 divided by root 2 over 2. They will equal to 1, but just for the sake of the question, we'll write them as they are. So let's just get all of these together in here. Okay, divided by 1 minus the product of these two together. So not addition, but multiplication. Okay, we put this entire value in the calculator, and it will give you, I believe, 2 plus root 3, maybe. Let me get my calculator to make sure that you have the correct answer. So here, let's try it. 1 over 2 divided by the root of 3 over 2. Make sure that you don't make any silly mistakes here. I messed it up. Well, in case you get 2 plus the under root of 3, congratulations. Now we can move on to the fourth question. So what is sine x times sine 2x plus cosine 2x times cosine x? So this is similar to the cosine formula, but since we have here plus, it should be minus. So here we have the value of a, because it's in inverse. The cosine should be in first, which means that a is going to equal to 2, minus, because here we have plus, minus x, which is 1. Okay, or this should be 2x minus x. Okay, which will give us cosine x, and this is going to equal 1 over 2. So they're asking us what is cosine x. What is x if we put cosine to the other side? It will be x is equal to cosine inverse of 1 over 2. I'm not sure, because here they didn't provide us with any determinants. I'm not sure if you provide them all or just the answer, but just for the sake of the question, let's just write all of them. So we've already done this one. This will equal to 60 and 300, as we've done it here in the second question, 60 and 300. Finally, to the last question. Is it? Yeah, it is the last question. Okay, so to the last question, we have cosine 2x plus cosine x is going to equal sine squared x, and they're giving us the determinant of 0 to 2 pi. So first of all, our first step will be converting this into cosine. How will we do that? Well, if you remember, I said that sine squared x plus cosine square x is going to equal 1. So if we put cosine to the other side, sine square x is going to equal 1 minus cosine square x. Okay, so we'll take this value and copy, and instead remove this one, because this is equal to this. So we remove this and we'll put this instead, and this will equal to cosine square x plus cosine x. Okay, so we can put both of these values to the other side. So negative square x, cosine square x, we put it to the other side, that being negative. So make us, it will give us 2 cosine square x, and then positive 1 we'll put to the other side. So it'll be here plus cosine x minus 1 is going to equal 0. Now, don't mind the cosine here. This equation looks like as if it was 2x squared plus x minus 1 is going to equal to 0. So how do we factor this? We factor this by writing. Okay, let's just remove some of the stuff here. Okay, can remove the things I need. So just let's remove some space here. Okay, yeah. And let's get this here to the other side. So how do we factor this? Well, basically we write 2x minus 1, I believe, times x plus 1. So let's write it this time with cosine. So it will become 2 cosine x plus 1 times cosine x minus 1. Okay, now let's get the root of each of these. So the root of this will equal to 2 cosine x plus 1 is going to equal to 0. So if you put 1 to the other side, it will be negative 1. And then, no, sorry. Plus is in the other side. Here's plus and here's minus, mind me. So this, just remove it. So it will be 2 cosine x minus 1 is going to equal to 0. So we put negative 1 to the other side. So it will be 2 cosine x is going to equal to 1. Divide by 2 to get cosine only. It will be cosine x is going to equal 1 over 2. Again, we've already solved for this, but let's just leave it for here. Let's just leave it here for a second. So this is for the first formula. And for the second formula, where is it? Let me try to find, yeah, here. Cosine x plus 1 will equal to 0. So we put 1 to the other side, it will become cosine x equals to negative 1. Okay, so let's get the inverse of each of these. So it will become cosine inverse of negative 1 will equal to x, and here cosine inverse of 1 over 2 is going to equal to x. Okay, so we already solved for this multiple times. We've said that this is equal to 60 and 300 degrees. Okay, because they told us here, where is it? Yeah, from 0 to 2 pi. So we write all of them. So 360. And finally, cosine, the inverse of cosine negative 1 will be, if we just look here, where do we have in the x value, where do we have negative 1? We have it in the angle 180. So here we have 180 and 60 and finally 300. These are the angles, or the 3 angles that are asked for in the question. Okay, let's just get these back together. Okay, so now in case we don't have a unit circle and you don't know how to get a cosine, we can use a very simple trick. If we have here, we know that a unit circle is going to be divided like this. And if we just use simple graphing skills, we will know that if this was 0, this will be 1, and y will still be 0 because we didn't write anything. And if this was 0, then y will be 1. Okay, here it will be negative 1, 0. And finally, here it will be 0, 0, negative 1. And as I've said, this will represent x and y, x and y, x and y, x and y. And we've already said that this will represent cosine, x represents cosine and y represents sine. So let's just get these two together. Copy. So here, this is for each of these. Okay, so finally, if we said that we want the cosine inverse of negative 1, and we already know that cosine is in the x value, so let's look for negative 1. It's on here. And we already know that this angle is going to equal to 180 because it is half of the circle. The entire circle is equal to 360 divided by 2, it will equal 180. So this means that we can find it even without a calculator nor the unit circle. That being said, I believe that we have finished the revision session. I hope that you understood everything. Again, if you didn't understand anything, just text me. I can re-explain anything if I explain something poorly. And if you also wasn't able to solve this question, because it's not like this, you want the determinant, it won't equal negative 1. I think it will equal 43. So I have to divide each value by 43 until it become a bit messy. So don't worry, you're not doing a mistake. It's a bit messy in there. But if you can get it, I will explain it to you. That being said, thank you everyone for the attendance, for attending this revision session, and have a nice day.